Alright students, we're going to go over these wave calculations today. So we have two different formulas that we're going to be using. One formula is the speed of light formula and the other is the energy formula. So the speed of light formula is going to be your speed of light equals your wavelength times your frequency. So first off, I'm going to change this F here. That should be frequency. We usually use this little fancy V to represent frequency. Our speed of light is always going to be the same, 3 times 10 to the 8th meters per second. All waves travel at the same speed. Wavelength is going to be measured in meters, and our frequency is going to be in hertz, which you can also see represented as a 1 over seconds, or sometimes you can see it represented as seconds to the -1. Now, frequency and speed are often understood by students. Speed is how fast the wave is traveling, and they all travel at the same speed. Frequency is how many waves are going to pass the point at any given time, and you should have seen frequency represented in our last video about waves and light. So if the question is talking about frequency and wavelength, you know you're going to have to use the speed of light formula. Speed of light is equal to the wavelength times the frequency. So our speed of light is a constant. It's always going to be 3 times 10 to the 8th meters per second. We do not use constants as far as sig figs go. We'll use what's in the problem for sig figs. Now we're solving for the wavelength, so that's going to be our x, and times our frequency, which is 6.01 times 10 to the 14 hertz. So in order to get x by itself, we're going to have to divide both sides by that 6.01 times 10 to the 14. So when you plug this into your calculator, don't forget, let me clear this out, you're going to use that EE button. So we'll have 3 second E 8 divided by 6.01 second E 14. Okay, notice there's no times, there's no funny business going here around the E. It's just an E. We'll enter that. We're going to have 3 sig figs because of the 6.01, so you should record your answer as the wavelength is 4.99 times 10 to the -7. And because that's wavelength, our unit is going to be meters. If you forget, just look back up here at the top. It tells you which units your answers are going to be in. For number 2, violet light has a wavelength of 4.10 times 10 to the -12. What's its frequency? Since it's talking about wavelength and frequency, we know we're going to use our speed of light formula. So speed of light is equal to wavelength times frequency. Our speed of light is always the same, 3 times 10 to the 8th meters per second. Our wavelength is going to be 4.10 times 10 to the -12 meters, and our frequency is our unknown. So to get and solve for frequency, we divide both sides by 4.10 times 10 to the -12. So our frequency then is going to be 3 second E 8 divided by 4.10 second E -12. And because the wavelength had 3 sig figs, 4.10, our frequency is going to have 3 sig figs, and we would round it to 7.32 times 10 to the 19 hertz, or 1 over seconds, or seconds to the -1. Okay? Give number 3 a try on your own, because we want to make sure you can use your calculator correctly. You should be getting a frequency of 3 times 10 to the 10th. So if you don't get that, make sure you reach out and let me know. Our next equation that we're going to be using is the energy formula. So its energy is equal to Planck's constant times frequency. Planck's constant is a number that they determined is an incremental increase of energy that these electrons travel. Our energy is going to be measured in joules. Our Planck's constant is 6.626 times 10 to the -34th. As constant, your constants and equations are on the back of your periodic table, so everything is right there for you to look at. And our frequency, again, is going to be in hertz, or 1 over seconds, or seconds to the -1. So when we're looking at number 4 here, Calculate the energy of a photon of radiation with the frequency of 8.5 times 10 to the 14. So we're solving for energy, and our equation is energy is equal to Planck's constant times frequency. We're given the frequency, so we can just go ahead and plug everything in. Our energy is equal to Planck's constant, which is 6.626 times 10 to the negative 34 joules times seconds, multiplied by our frequency, which is 8.5 times 10 to the 14 hertz. So we don't need to rearrange the equation over here. We can just go ahead and multiply 6.626 second E negative 34 times 8.5 second E 14. Because this only has 2 sig figs, our answer is only going to have 2 sig figs. So we should record our answer as 5.6 times 10 to the negative 19 joules, because we're solving for energy. Number 5, the frequency of a wave carrying 8.35 times 10 to the negative 18 joules of energy. We're given the energy. We're trying to solve for the frequency, so we need to use the energy equation. This time our energy is going to be 8.35 times 10 to the negative 18 joules, equal to Planck's constant, 6.626 times 10 to the negative 34 joules times seconds. And we're solving for our frequency, so that's our unknown over here. So to get our unknown by itself, we have to divide both sides by Planck's constant. And that will give us our frequency. So our energy was 8.35 second E negative 19 divided by negative 18 divided by 6.626 second E negative 34, and that gives us our frequency as, with 3 sig figs, 1.26 times 10 to the 16 hertz. Okay, I want you to try number 6 by yourself. You should be getting an answer of energy is going to equal 2.07 times 10 to the negative 15. So make sure you get that. Reach out if you're not getting that. For our last 2 questions, we're going to be using both formulas. So in this first equation, it says what is the energy, so we're solving for energy, of a 9.3 times 10 to the negative 3 meter wave. So this is representing wavelength because it's meters. Do we have one equation that relates the energy and the wavelength together? Nope. So since we don't have one equation, we have to do both. So you have to figure out which equation to use first. Do you use the speed of light equation first, or do you use the energy formula first? Because we're given the wavelength, we're going to have to start with our speed of light formula. So speed of light is equal to the wavelength times the frequency. Our speed of light was 3 times 10 to the 8th meters per second. Our wavelength is 9.3 times 10 to the negative 3 meters, and we're solving for our frequency. So in order to get our frequency by itself, we have to divide both sides by 9.3 times 10 to the negative 3. Sorry, that's so small. So we'll take our 3 second E8. It's always going to be the speed of light divided by something else when using this formula. 9.3 second E negative 3. Now we're not going to round to sig figs yet. We don't round to sig figs until the very end. So our frequency is 3.225806. You don't have to write down all the numbers. Times 10 to the 10 hertz. Once you get the frequency, you can go ahead and use the energy formula to solve for the energy. So we know that energy is equal to Planck's constant, 6.626 times 10 to the negative 34 joules times seconds, times our frequency, 3.225806 times 10 to the 10. Oops, I'm kind of overboard over here. Hertz. So I'm just going to take my answer in my calculator, multiply it by Planck's constant, and I'm going to round to 2 sig figs because of the 9.3. So my energy is going to be 2.1 times 10 to the negative 23 joules because we're solving for energy. Last question, what is the wavelength of a 1.528 times 10 to the negative 13 wave? We're looking for wavelength, but we're given energy. There's not one equation that relates the two of them together, so we have to use both equations. Are we going to start with our speed of light formula first or our energy formula first? Well, we're going to start with the energy formula because we're given the energy. So energy is equal to Planck's constant times frequency. Our energy is 1.528 times 10 to the negative 13 joules equals Planck's constant 6.626 times 10 to the negative 34 joules times seconds times our frequency, our unknown. So in order to get the frequency by itself, we need to divide both sides by Planck's constant. So we're going to divide this by 6.626 times 10 to the negative 34. So in my calculator, I would have 1.528 second E negative 13 divided by 6.626 second E negative 34. My frequency, remember I'm not going to round to sig figs until the very end. My frequency is 2.306067. I don't have to write all of the numbers, times 10 to the 20 hertz. Once I get frequency, I can go ahead and use the speed of light formula, which is C equals wavelength times frequency. My speed of light is 3 times 10 to the 8th meters per second. I'm solving for my wavelength. My frequency is 2.306067 times 10 to the 20. And to get wavelength by itself, I need to divide both sides by 2.306067 times 10 to the 20th. This will give me my wavelength. So I'm going to take my calculator, I'm going to take 3 second E8 divided by, and I'm just going to do second answer so I don't have to retype everything into the calculator. And I would get as my answer, rounded to 4 sig figs, 1.301 times 10 to the negative 12 meters. Alright, so give page 7 a try on your own so you can let us know if y'all have any questions.